Okay, so this video is entitled More Parametrics. Up here, notice the N. That means these are the notes. If there's an A here, that means it's the assignment. Okay, so the way I copied them is the notes are first in your packet and then the assignment. It says, complete the table and graph the following parametric equations for t in 0 to 2 pi. Now, you should notice here that in this case, t is not so much time, but an angle. Okay, what gives this away? 0 to 2 pi. And not just an angle, but an angle in radians. What gives that away? The pi. Okay, so 0 radians to 2 pi. So I've already broken it down for you, starting at 0 and going 90 degrees, or pi over 2 radians. I broke 2 pi down by pi over 2 radians. So we're going to use these two parametric equations to fill in our table. So filling it in, so x is equal to 5 times the cosine of t. Okay, so plugging 0 radians in, so the cosine of 0. Okay, you can do this one of two ways. The cosine of 0 is going to be, here's 0 radians. Cosine, the definition of cosine is x over r. So the x value is 1, and the radius of our unit circle is 1, so 1 over 1, so is 1. The cosine of 0 radians is 1. Times 5 is 5. Okay, y. Y, so the sine of 0, so remember the definition of sine is y over r, so y is 0. The radius is 1, so 0 over 1 is 0. 0 times 5 is 0. Now, you can use your unit circle. Another way to do this is to use your calculator. Make sure your mode is in radians. And then we want 5 times the cosine of pi over 2. Enter, and we get 0. 5 times the sine of pi over 2, and we get 5. So if you don't have a graphing calculator, you can use your unit circle to get these answers. Hopefully, you can think to yourself the coordinates at each of these radians. 1, 0, 0, 1, negative 1, 0, 0, negative 1, and then back to 1, 0 again. Okay, should have those memorized. So let's fill in the table and then let's graph these points. Okay, so the table's filled in. Hopefully you paused the video and did this. Plot the points from 0 all the way back to 2 pi. Then we drew our circle. Okay? So type of curve, we have a circle. And the center of our circle is 0, 0. And the radius of our circle is 5. All right, find the rectangular equation. So what we need here is we need an equation that has sine of theta and cosine of theta. So if you'll remember our identity, our Pythagorean identity, sine squared of theta. In this case we use t instead of theta, but we know that it's an angle. Sine squared of t plus cosine squared of t equals 1. Okay, so now next thing we want to do is we just want to plug it in. So up here we're going to take this equation and we're going to solve for the sine of t. So y equals 5 sine of t. So to solve for sine of t, we're going to divide both sides by 5. So that means the sine of t is equal to y over 5. So plugging that in, y over 5, it's squared, plus, if you solve this one for cosine of t, divide both sides by 5, we're going to have x over 5 squared equals 1. Okay, we're now in rectangular form, but what we want to do here is we want to simplify this out. So squaring both terms, we get y squared over 25 plus x squared over 25 equals 1. Get rid of the fraction, multiply everything by 25. Multiply the whole equation by 25, and we get y squared plus x squared equals 25. And that is our rectangular equation. Okay, problem number 2. Complete the table and graph the following parametric equations for t in 0 to 2 pi. Again, we're dealing with an angle in radians. Notice how these parametric equations are different than the last ones that we dealt with. I wonder what the 2 and the 2 adding to, what will that do to our graph? Well, let's find out. So cosine of 0 radians is 1. 1 times 3 is 3 plus 2 is 5. The sine of 0 is 0 times 6 is 0 plus 2 is 2. Okay, continue to fill out the table and plot the points. Okay, so here we go. Here we have an ellipse, a vertical ellipse, okay? Now, what's our center? Well, very simply, if you count your horizontal, you have 1, 2, 3, 4, 5, 6. So half of 6 is 3. 1, 2, 3. Again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Half of 12 is 6. So our center is at 2, 2. So we have an ellipse. Center is at 2, 2. Our x radius right here is 3. Our y radius right here is 6. It's important. Okay, it's important. Now we want to find the rectangular equation. Again, we need that equation that's using sines and cosines. So sine squared t plus cosine squared t equals 1, Pythagorean identity. And again, we're going to take these equations and solve for cosine t and sine t. So go ahead and pause the video and do that. Okay, here's your first equation. We're getting cosine t by itself, so I subtracted 2 on both sides. Then divided by 3 on both sides, cosine t is equal to that. Okay, let's try the other one. Okay, if you did the other equation correctly, you should have came up with sine of t equals y minus 2 over 6. Now that we have them solved, we can plug them in. So we're going to plug y minus 2 over 6 in for sine of t. We're going to plug x minus 2 over 3 for cosine of t equals 1. Okay. Next thing we want to do is we're going to square the top and the bottom. And so we get y minus 2 squared on the top over 36 plus x minus 2 squared on the top over 9 equals 1. Now remember, for ellipses, we want the equation to be equal to 1. Here is your y radius, 6, under the y term, and here is your r radius of 3. Remember, we take the square root of that number on the bottom to get the radiuses. It's under the x term. X radius, y radius. Okay, parametric equations of a circle or ellipse. So for x, we have h. Remember, h moves left and right. That makes sense, left and right. Plus a, which has to do with our stretch or compress. Cosine of t. Okay? And it also has to do with our horizontal radius. Okay? So that's going to be, has to do with a. Okay, k is up and down, so k plus b sine of t. So b is going to be our y radius, stretches it or compresses it. K is our movement up and down, so our center point is going to be h comma k. H comma k. Check it out up here. 2 comma 2. Right there, our center. Okay. The graph will be a circle if A equals what? What do you think? You fill that in. I want to see if you can figure that out. Okay. The center, again, is h comma k. Okay. I'm looking for this answer. Think about it. Okay, so number 3, unless you have a graphing calculator at home, we're going to go ahead and do this one in class. Please remind me in case I forget, okay? All right, moving down to number 4. It says write parametric equations. So here we have a regular function, and I want to write 2 equations, one for x and one for y, but we want them to be in terms of t. So very simply, x is our independent variable, okay? So I want to make x be equal to t, okay? And then once I have made x equal to t, I can rewrite this function as y equals 3t squared plus 5t minus 1. Again, I make x my independent variable, t, and then I rewrite the equation in terms of t. Okay, obtain a complete graph on your calculator for t in -2, 2. Use the table to make a sketch of the graph, show your scale. Now, let's not use our calculator here. Let's go ahead and go over here, make a table, and t is going to go from -2 to 2. X, y. Alright, so go ahead and take these t values, plug them in, and get your points, and then graph them, please. Okay, really quick. Hopefully you came up with this free table. Hopefully you're not just copying them down. Hopefully you're plugging the numbers in and making your table. I set up my scale from -4 to 4 for my t, and -25 to 25 for my y. Or I should say my x and my y. Okay, so now we're going to graph these points. Go ahead and stop the video now. Alright, once you have plotted your points, you should get part of a parabola as your graph. Okay, next example. For the next parametric equations, we want to sketch a complete graph. Show your scale on the axis. So we're going from 0 to 4 pi. So go ahead and stop the video and see if you can do this on your own. Okay, so when you plug the t's in, this is what you get out. Plotting the points, we got 0, 0. We got -pi0. We got 2 pi 0. We got -3 pi 0 right here, and -3 pi 0. So it's going to go around in a circle just like this. Kind of interesting. To make it a little bit better, it would be helpful to have done the ones in between, like pi over 2, 3 pi over 2, and so forth. Okay, we'll do number 6 in class. Have a good night.